Welcome back to the Professor's DuBois channel. I am Victoria and this is Corey, and we are going to be talking about electrolytes today.
So before we go right into a definition of electrolytes, we want to know how do we know if a dissolved compound dissociates? Now, in the previous lecture, we talked about dissolving and dissociation, and we said if something dissociates, it'll make ions in solution. So we need to have an ionic compound that will dissolve to dissociate. So a molecular compound may dissolve, but it won't form ions. So how do we know that if this compound makes ions?
Right.
That's the question to get us started with this term electrolytes.
And what we would do is, at least certainly early on when we were trying to learn all of these things, it would be, does it conduct an electric current? We have fancy equipment now that we can have a conductivity meter which can determine exactly how conductive something is, but this apparatus that you're seeing right now certainly would tell us if there are ions in solution. So if there are no ions in solution, if you have something like ethanol or some other molecular substance that does not break down, like our sugar example in our last video, it would not conduct an electric current. So you need charge that moves to have a current, right? So we would not light the light bulb here. In the second example, though, we have KCl. That is a soluble ionic compound. So when it dissolves in water, it dissociates into its ions, and it would create that current when we put this, we have these electrodes in this solution. It would light that light bulb. And we also have acetic acid here as an example, and this acetic acid is just kind of dimly lighting that light bulb, and we're going to come back to that and kind of try to understand why that is. So if it conducts electric current, then we do have at least some ions in that solution.
I remember too from the previous lecture that all acids are soluble, so that acetic acid is soluble in water, but apparently it doesn't form a whole lot of ions.
Mm-hmm.
So strong electrolytes. We're back to this electrolytes. We have strong electrolytes, and these are soluble ionic compounds that 100% dissociate into ions. Now, I said ionic compounds, but there's also another group of compounds, and these are the strong acids, and there's 6 of these strong acids. We're going to get to those in a second. So we can write a dissociation, or I guess we could call this a dissolution reaction, but it is a dissociation because we're forming these ions, and you can see we're starting with solid sodium chloride, and we have the arrow going to the ions, and now these are aqueous, so that means that they have dissolved in water.
Yep. So soluble ionic compounds, strong acids, are what we call strong electrolytes. They dissociate completely. So 100% that dissolves, breaks apart.
Bright light bulb.
Bright light bulb. So no light in the light bulb are non-electrolytes. So compounds that can dissolve, but not that don't conduct electricity, like our sugar example, would be a non-electrolyte. Or our ethanol example, our alcohol example, antifreeze, sugar, ethanol, these are all examples, and they are made up of nonmetals. So some like our strong acids are also made up of nonmetals, but they are the 6 strong acids that we're going to talk about in a minute. But most molecular compounds are not going to break apart, and they do not form ions. Couple exceptions like our acids.
So weak electrolytes, think dimly lit bulb as opposed to a bright lit bulb.
What are you calling me?
With that apparatus. Weak acids and weak bases, they are molecular compounds, but they do partially dissociate. So that means that they do form some ions, but it's a small amount of ions.
Yep, less than 1 to 5% is kind of the rule of thumb there. All right, here's our 6 strong acids. These you want to memorize. You do want to know these. They are right here. So hydrochloric, hydrobromic, hydroiodic, nitric acid, sulfuric acid, and this is perchloric acid, HClO4. that means that if they're strong, that means that when they dissolve, because they're all acids, they're all soluble, 100% broken apart into its ions, strong electrolytes.
If you look at your periodic table, you'll see like the HCl, HBr, HI, the anion is in group 17. And quite often you'll see an acid HF, and that's also in group 17, not a strong acid. So
tricky.
Be aware of that and realize that, you know, you can identify 3 of these because the anion's in group 17, and so you have half of them. But certainly write these down, be familiar with them, realize that these are strong acids and they are strong electrolytes.
Yep. And if it isn't strong and it's an acid, then it's weak. There are a lot of weak acids in the world, so you only need to know the 6 strong ones to know that everything else that's behaving as an acid is what we call a weak acid. You should also know that NH3, that's ammonia, is a very common weak base that we use in chemistry a lot, so you should know that NH3 is ammonia, and you should know that it is a weak base.
And it's a weak electrolyte.
Okay, so to be an electrolyte, it must be soluble and form ions. Remember that all acids are soluble, and ionic compounds, you're going to have to look at your solubility table to see if it's soluble. Once it's soluble, then you can determine if it's a strong electrolyte, a weak electrolyte, or a non-electrolyte. I like this table.
Yeah, this is just a nice summary chart. So we start at the top. It's kind of like a flow chart. We have a solute. Remember, we have, in an aqueous solution. So that means we have water. That means we have a solution. Now, a solution's made up of a solute and a solvent. If it's an aqueous solution, the solvent is water. So if we have a solute in an aqueous solution, it can either be an ionic compound or it could be a molecular compound. If it's an ionic compound and it dissolves and it forms solution, then it's a strong electrolyte. So it's going to form the ions. If it's a molecular compound, it could be an acid or a base. If it's a strong acid, that's a strong electrolyte. There's 6 of those strong acids. If it's a weak acid or a weak base, then it's a weak electrolyte. So this is a dimly lit bulb. I brought back the dim bulb.
Nice.
But most of the molecular compounds are not electrolytes, so they don't form ions in solution. So something that's missing in this flowchart is, what about strong bases?
They're over here.
Strong bases are ionic compounds, and that's something you'll
common mistake there.
As we start to talk more and more about bases, you'll realize that bases are ionic compounds. Strong bases are ionic compounds.
Yep. Here's your practice. All right, so for this one, you're going to first determine if it's soluble or insoluble. So you'll need your solubility chart to be able to do this. So take that out. If it's soluble, then I want you to determine if it's a strong, weak, or non-electrolyte. So get your solubility table out and pause the video. Here's your answers.
It's something I want to point out here, like for question number 2, this was a molecular compound. And so that's why we told you that it was polar, and using like dissolves like, we know that this is soluble, but it's not an electrolyte, because the only molecular compounds that are going to be electrolytes are the acids or bases.
Yep. Thanks for watching. Anything to add? No? Take care.